Okay, let's give you guys some more practice. So here you've got a graph of y equals arctan of x. So that's this graph here. Looking at this purple area here, if you rotate it 360 along the x equals 0 axis, you will trace out a 3D solid. Work out the volume of that 3D solid. Okay, so press pause. From 0 to 1. So work out the volume of that solid. So press pause and have a go. Okay, so to do this, we're going to sum up all the shells from 0 all the way to 1. So it will be something of the form from 0 all the way to 1. And if you look at the thickness of this thing here, if you're moving in the x direction, the thickness will be dx. So it will be something in the form of something dx. And then we would need to know the radius of this thing. Well, the radius of this thing is x, and then we need to 2 pi r it to get the circumference. So we need to times 2 pi. So this here 2 pi r will give us the circumference of the shell, and then we need to find the height. Well, the height of this thing is arctan. So it would be something like this. It would be from 0 to 1, 2 pi r, which happens to be x, and then we need to times the height. So remember, we need to times the height of our shell. So the height, this height here is arctan or inverse tan of x. Okay, and then dx. So the volume, if you rotate it 360 around the x equals 0 axis, you will get a 3D solid. The volume of that solid is given by this. Okay, so the volume is given by this. So now we need to evaluate this integral. So 2 pi is a constant. So take it out. That will then take you to here. So now it's just a matter of evaluating this. So now use integration by parts. So integration by parts will so now we just need to evaluate this. So let this here be v prime, and then let this here be u. Well, if this is u, then u prime equals this. So if this is u, then u prime equals this. And we've done this many times. Let me just switch screens. So we've done this many times. If you differentiate arctan of x, it would give you this. And we've done this many times. So you would, well, blah, blah, blah. We've done this many times. So if you differentiate this, it will give you this. So let me switch back. So now, so if we let u equals this thing here, then u prime equals this thing. If we let v to be this, if we let v prime to be this, then normal v would be this. So now blindly follow this. It's saying get u times v. It's saying get u times v. So that would be x squared over 2 inverse tan of x evaluated evaluated from 0 to 1. And don't forget, we've got the 2 pi here. So by right, we should have 2 pi in front here. Okay, and then minus this minus here. That's this bit here. The integral, and then it's saying the integral from 0 to 1, and then it's saying u prime times v. So that would then give you, hang on, it's saying get u prime times v. It's saying get u prime times v. So that will be hang on, that will be x squared over 2 bracket x squared plus 1 and then dx in here. Okay, well, to do all that, all this here will then become this. Okay, it will then become this. So now let's take this half out. It's a constant, so take it out here. So that will then give you this, and also so we are currently here. Okay, so you can see that this here is a half. a half is a constant, so you can take it out here. And then also looking at this here, if you evaluate this, so remember, if you evaluate this, so you've got to put this, so if you evaluate this, it would be this thing, take away this thing here. Okay, so this thing here would then give you this, and then you've got to then you've got to put this into here and into here. Well, inverse tan of 0 is 0. Well, this whole thing here, if you evaluate it, it will give you this, because this thing, which is this bit, take away, and then this thing, which happens to be 0, because when you put 0 into inverse tan, it will be 0. Well, this whole thing here will be this. Okay, and this half here, take it out, that will then give you this. And then if you look at this here, we could use polynomial division here, but let's just use our trick, our old trick. Our old trick was to add 1 and then take away 1, and then this thing here will be, well, from here, if you take a half is a constant, take it out, that will then give you this, and then rewrite the rest in this form here. So that will, and then from here you can break it up into 2 fractions. This thing here will be 1, and then you've got a negative, you've got minus, sorry, you've got minus, oops, you've got minus this thing here. Well, break this up into 2 fractions, it will then give you this. Okay, and then don't forget you've still got a minus out here. Well, blah blah blah, it will then take it to here. Okay, and then from here integrate it. That will then give you this, and then let me think. Oh yeah, I forgot to mention up here. All the 2's cancel out. Well, blah blah blah. From here, that will then take you to here. Evaluate it. It will then take you to here, and then blah blah blah. It will. The overall answer will be this. Okay. And just remember that inverse tan of 1 is a quarter. So because if you look at a circle, when tan is really when the height, tan of 1, inverse tan of 1 is when the height, inverse tan of 1 is when the height here equals the width here. So when will the height and the width be the same? It's when, well, this here is pi over 2. So cut it. Well, inverse tan of 1 is pi over 4. So you put it into here, and then the overall answer will be this. Okay.